Hello viewers, welcome to another session of my tutorial, and today we're going to talk about how to find the RMS value of some waveform. And now we have this waveform here, which is a sinusoidal wave in addition to a right angle triangle wave, and it repeats in that way. So we have the period, that is 2 pi. So it starts from 0, then it begins again at 2 pi, and this is our peak voltage, that is Vm. So we have to find the RMS value for this waveform. To find that, you need to find the area of the square cycle and divide it by the period, then you square root the whole thing. So to find the RMS of this is simply equal to the square root of the area of the squared cycle, square root of everything over the period. So our aim right now to find the area of the squared cycle. So to find the area of the squared cycle, we can see that this waveform is in two shapes. This is a sinusoidal shape and this is a triangular shape. So you have to find the area under the sinusoidal shape or the sine wave. So area under the squared area, the area of the squared cycle. So area under squared sine part. So that one, we know that to find the area, we apply integration here. So that is going to be integral of 0 to pi of the squared. So you know that for a sine wave, its normal waveform is Vm sine theta. So for here, the squared is going to give us Vm squared sine squared theta d theta. That is our integral that you are going to find the value of. So here we put the Vm squared because it's a constant out. So you are going to get Vm squared 0 to pi of sine squared theta d theta. Then from here, we know that sine squared is also equal to sine squared theta is also equal to 1 minus cos 2 theta all over 2 from trig or trigonometric function. Now we can prove that simply quickly by doing, you know that cos 2 theta is equal to cos squared minus sine squared theta, and you know that cos squared here is the same as 1 minus sine squared theta. So 1 minus sine squared theta minus sine squared theta. Here we get 1 minus 2 sine squared theta. When you make this a subject, you're going to get 2 sine squared theta is equal to 1 minus cos 2 theta, and we divide through by 2 to get sine squared theta to be equal to this. So we just quickly move to solving the integral value for Vm squared integral 0 to pi of 1 minus cos 2 theta all over 2. So from here, 1 over 2 is a constant, we move it out, we get Vm squared over 2 integral of 0 to pi 1 minus cos 2 theta now. So once I get this, I can split it using the integral rules. So I'm going to get Vm squared on 2, open bracket, integral 0 to pi of 1 minus integral 0 to pi, so 1 d theta, integral 0 to pi of cos 2 theta d theta. So I've got 2, I've splitted them. So from here, I'll do this one separately and this one separately. So for this one, I'm going to get Vm squared all over 2. When I integrate this 1 d theta, I'll get theta. So I'm going to get theta, then pi, then 0 minus. Now for this one, we have to use the substitution method where we make u is equal to 2 d theta. So if I make u to be equal to 2 theta, the u over the theta will give me 2. Now from here, I want to make the u the subject. The u is going to, I want to make the theta the subject. The theta is going to be 1 over 2 du. So if I make the substitution, I'm going to get something like this minus integral 0 to pi of cos u, because 2 theta is equal to u, of cos u. Then I'll bring my 1 over 2 du as here nicely. So from here, we can even make u the sub. When you are doing integral and it's definite and you use u, you can change the power, you can change the limits. So if u equals 2 pi, if I put pi inside, I'll get u is equal to 2 multiplied by pi, and that will give me 2 pi. Then when I put 0 inside, I get u is equal to 2 multiplied by 0, and this is equal to 0. So this is basic integral concept. So I'll get upper limit now to be equal to 0, then 2 pi. That is with respect to u. So here I'll bring my half outside again. So I get my Vm squared on 2. Then here, if I put the upper limit, which is pi, I'm getting pi. 0 is 0. So I get pi minus 0. That will be pi. So pi minus this whole thing. That will give me half integral of 0 to 2 pi. And then cos u du. So to integrate cos u du, you know that integral of cos u is the same as sin u. So that will give me Vm squared on 2 all over, minus, open bracket, pi minus half, then sin u, my upper limit 2 pi, then 0 finally. So from here, Vm squared over 2 pi minus, so here if I put 2 pi inside, I'll get sin 2 pi, that is sin 360, and that is 0, and sin 0 is 0, so everything here becomes 0. Then finally, my area under the square cycle becomes Vm squared pi on 2. So this is the area under the square cycle of the sine wave. Now let's go to the area under the triangle part, that is a right angle triangle. So considering the area under the right angle part, so right angle triangle part, right angle triangle part. So I'm going to have, you know that to find the cycle of this triangle part, you just make y is equal to mx plus c. That's the equation of a line. But here it is lying on the y-axis, so it has no c, and the c is equal to 0. So here we're going to get y is equal to mx. But my y is the top part, that is this part, the ordinate. So that is going to be my e. That is what I want, the cycle of the triangle. So it's equal to, now this is the gradient. The gradient is the y value, that is the Vm on pi, that is y over x, and our y is Vm, and our x is going to be pi. This minus this, from here to here is pi. So I'll get Vm on pi, then my x is my theta here. I didn't introduce, so it's theta. So Vm over pi, then theta. So this is a cycle I'm going to use to do my integration. So from here, I have my cycle here, then I'm going to square this. If I square this, that is e squared will be equal to Vm squared over pi squared multiplied by theta, that is all squared. So from here, I'll just introduce my integral 0 to pi of this cycle, Vm squared over pi squared, then theta also squared, the theta. So if you have this, you go on with your integration. You know that Vm squared over pi squared, they are all constants. You bring them out so that you get Vm squared pi squared integral 0 to pi of theta squared the theta. Now in integration, add 1 to it and you divide it by the resulting value. So you get Vm squared over pi squared. If I add 1 to the 2, I get 3. So then I'll divide through by 3. So I get theta cube over 3 pi, then 0 nicely. So once I get this, I'm going to get, if I put pi inside, I'll get Vm squared over pi squared. This is putting the upper and the lower limit. So I'll get pi cube over 3 minus 0 cube over 3. Here will be 0. So I'll get Vm squared over pi squared. Then also open brackets, pi cube on 3. This pi squared will cancel this, and I'll finally get Vm squared multiplied by pi, everything on 3. So this is also the area under the square triangle part. So the total area under the square cycle will be the area for this one That is Vm squared pi on 2 plus Vm squared pi on 3 for the triangle part, pi on 3. So from here you can see that the area under the squared cycle of every rectangle triangle wave is equal to Vm squared pi on 3. So it's constant. The same for the sine part, Vm squared pi on 2. So when you add this, what are you getting? So different bases, so you're going to get, if you multiply this then multiply here, you get 3Vm squared pi plus 2Vm squared pi all over 6. And finally I'm going to get 5Vm squared pi on 6. Once I get this, I'm not done. This is the area under the square cycle. I'm to divide it by the period before I take square root of the whole result. So if I divide it by the period, what's the period? The period is from 0 to 2 pi, 0 to 2 pi. So to get from 0 to 2 pi, that will be your period. Period is where it begins and where it begins again. So it started here and it's now beginning here again. So from here, I'll just write this divided by my 2 pi. So it becomes 5Vm squared pi on 6 times 1 over 2 pi, where this pi will cancel this pi, and I finally get 5 on 12 Vm squared. So once I get this, I'll just take square root of my resulting solution, since the initial formula is square root of the area of square cycle over period. So square root of 5 Vm squared on 12 nicely. So here Vm can even come out, but this is the actual solution. So this can also be equal to Vm root of 5 on 12, or this is the final solution to find our RMS of this whole waveform. Thank you for watching my video. Kindly subscribe and share.